Hello students, welcome to EPG Pathshala. I am Dr. Renu Tyagi from Sardar Patel Institute, Ahmedabad. Today we are going to talk about the module Obesity and Ethnicity under the paper Physiology and Sports Anthropology. Let's have a look at the learning objective of this module. After finishing this module, we will be able to understand the concept of race or ethnicity. We'll try and understand the relation between obesity and ethnicity. We'll come to know about the prevalence of obesity among adults using different parameters. And we'll know about the prevalence of obesity among children with different parameters. Ethnicity is a term used to categorize the population on the basis of cultural characteristics such as shared language, ancestry, religious traditions, dietary practices, and history. Although ethnic groups can share a range of phenotypic characteristics due to their shared ancestry, the term is typically used to highlight cultural and social characteristics instead of the biological ones. The term race has traditionally been used to categorize population on the basis of biological characteristics which they share among them, such as gene, skin color, and other physical features. Both race and ethnicity are in fact social construct. The idea that race reflects only biological distinction is not true. Only 3.7% of the total human genetic diversity may be based on the race, but are not always biologically meaningful. Both the concept, that is race, and ethnicity are continuously evolving ones. This makes comparing groups or following the same groups over time a challenging task. Admixture as well as the changes in self-identification across several generations make it difficult to categorize the individuals according to the race or ethnicity. Therefore, defining ethnicity, the concept of ethnicity is important. The concept of ethnicity or ethnic group is multidimensional. It changes with time and it is difficult to define as well. When a person identifies with a particular ethnic group, it may simply have a shared origin, social background, cultural or traditional background which are distinctive and maintained between generations. Furthermore, in a world of migration and mixing, these culture and societies are highly dynamic. It is virtually difficult to create single mutually exclusive categories of ethnicity which invite the identification from the respondents and are conceptually coherent. Whenever data is collected and analyzed on a large scale, the ethnicity is often treated as a fixed characteristics. The term minority ethnic group are used in UK, which is based on the UK census, which asks the people to indicate the ethnic group they belong to. The country of birth is sometimes used as a proxy for the ethnicity. Let's have a look at obesity and ethnicity. Obesity prevalence varies substantially between ethnic groups, both among adults as well as among the children. Estimates of adult obesity prevalence by ethnic group seems to differ according to the measurement used. Some of the measurements are body mass index, waist to hip ratio, and waist circumference. The definition of obesity is a topic of debate among adults and children belonging to different age groups. Different ethnic groups have different physiological responses to fat storage. Body mass index cutoff values for obesity has been revised for South Asian population who are at risk of chronic diseases and mortality at lower body mass index level than the European population. Obesity is a chronic condition characterized by the excess of body fat. The Royal College of Physicians of London, in its report on clinical management of overweight and obese parents, has taken body mass index as a measure of body fat. Body mass index, that is BMI, is calculated as a weight in kilogram divided by the height in meter square as originally described by the Quetelet in 1869. Let's have a look at obesity among adults. The World Health Organization clarification to define the degree of overweight has been accepted internationally and also by the National Institute of Health NIH in 1998, which was revised later in 2000. According to their standards, the person having a BMI of less than 18.5 is classified as underweight, and they have a risk of low comorbidities or risk of other clinical problems increased among them. The person of normal BMI between 18.5 to 24.9 kg per meter square is found to have an average risk of comorbidities. Person of overweight BMI, that is between 25 to 29.9, have the mild increase of the risk of comorbidities. The obese people who are further classified as class 1, class 2 or class 3 type of obese are found to have the moderate, severe or very severe risk of comorbidities respectively. Conventional adult BMI clarifications relating to excess fat are BMI equal to 25.9 to 29.9 kg per meter square as overweight, whereas BMI equal to 30 kg per meter square and above as obese. These cutoffs are primarily applicable to European population to correspond to the risk threshold for a wide range of chronic diseases and mortality. Worldwide, disease profiles are transforming at a rapid pace. Among several diseases, obesity has become a colossal epidemic causing serious public health concerns and contributes to 2.6 million deaths worldwide every year. Obesity is an independent risk factor for cardiovascular diseases. Obesity is associated with an increased risk of morbidity and mortality as well as reduced life expectancy. Now let's see the BMI cutoff point for different ethnic groups. In recent years, there has been a growing debate on whether there is a possible need for developing different BMI cutoff point for different ethnic groups, in particular for Asian population. This is due to the increasing evidence that the association between body mass index, percentage of body fat and body fat distribution differ across population, and therefore the health risk increase below the cutoff point of 25 kg per meter square that defines overweight in the current WHO classification. There have been two previous attempts to interpret the BMI cutoff point in Asian and Pacific population, both of which contributed to the growing debate. To investigate these questions further, the World Health Organization held an expert consultation on BMI in Asian population. The consultation concluded that the proportion of Asian people with a high risk of type 2 diabetes and cardiovascular disease is substantial at BMI lower than the existing WHO cutoff point for overweight, that is more than 25 kg per meter square. However, the cutoff point for observed risk varies from 22 kg per meter square to 25 kg per meter square in different Asian population. The consultation therefore recommended that the current WHO BMI cutoff point should be retained as the international classification. However, the cutoff point of 23, 27.5, 32.5 and 37.5 kg per meter square are to be added for public health action points. This recommendation stated that countries should use all BMI categories for reporting purposes with a view to facilitate the international comparison. In addition, an expert working group was formed by the WHO and is currently undertaking a further review and assessment of available data on the relationship between waist circumference and morbidity and the interaction between BMI, waist circumference and health risk. It is now well established that adult Asian subjects have higher level of body fat than European subjects with comparable BMI values, which has led to the revision of the WHO recommendation for appropriate BMI cutoff level in the Asian population. Obesity is a type of malnutrition which is highly prevalent, readily visible, and symbolized by the prolonged energy with resultant excess accumulation of fat and formation of superfluous adipose tissue. It's important to remember that though BMI correlates with the amount of body fat, it does not directly measure the body fat. Other methods of estimating the body fat and body fat distribution include the measurement of skin fold thickness and waist-hip circumference, calculation of waist-to-hip circumference ratio, and techniques such as ultrasound, computed topography, and magnetic resonance imaging, that is MRI, are emerging along with the bioelectric impedance, etc. Recent studies have shown that waist circumference is the best simple anthropometric index of abdominal visceral adipose tissue. Let's have a look at the waist-hip ratio, which has been used to differentiate the distribution of body fat for lower body fat predominance, the ratio. Epidemiological studies have mainly used ratio of waist to hip circumference to estimate the proportion of abdominal adipose tissue. Males with high waist-hip ratio of more than 1 and females with the waist-hip ratio of 0.85 are considered as obese. Although measures of central adiposity are closely correlated with the BMI, they have been shown to predict the future ill health independently of the body mass index. Current waist circumference thresholds for the increased risk of obesity related health issues among white population are 94 cm or more in men and 80 cm or more in women. The equivalent thresholds for a greatly increased risk are 102 cm for men and 88 cm for the women. The International Diabetes Federation and South Asian Health Foundation are in agreement that the cutoff for the waist circumference from the South Asian and Chinese ethnic group should be reduced from 94 cm to 90 cm to represent the increased risk. However, no change from 80 cm has been recommended for women. However, there is no universal optimal value that can be applied worldwide, country or region specific threshold values which are generally considered. In UK, however, NICE does not recommend separate waist circumference threshold for different ethnic groups. The Health Survey for England in 2004 had a large sample of individuals from minority ethnic group and gives a large data on adult obesity prevalence by ethnic group. It was reported that men from Irish, Pakistani, Indian and Bangladesh groups have similar prevalence of raised waist to hip ratio as compared to the general population. Men from Black African, Black Caribbean and Chinese communities were not having higher waist to hip ratio. Women belonging to Bangladesh, Black, Caribbean, Pakistani and Irish group had raised waist-hip ratio compared to women of general population. Bangladeshi women showed values which are twice higher. Waist height ratio has been proposed as a good measurement which can be used across all ethnic groups. In population of Japan and China, where low rates of obesity and moderate BMI are prevalent, the waist height ratio could be used as an indicator for lifestyle-related disorder. The present graph also shows the distribution of waist height ratio in different countries. Normally, 18 to 22 kg per meter square BMI, the overweight BMI values of 23 to 24.9 kg per meter square, obese BMI value of more than 25 kg per meter square, the waist circumference and waist hip ratio cutoff for Asian Indian abdominal obesity is increasingly being recognized as an important cardiovascular risk factor. In some studies, association of abdominal obesity with various metabolic risk factors appears to be stronger than generalized adiposity. The cardiovascular risk associated with abdominal obesity can be attributed to excess abdominal adipose tissue, both intra-abdominal adipose tissue and subcutaneous adipose tissue. Common surrogate measure of abdominal obesities are waist circumference and waist hip ratio. Waist circumference is a simple, easily obtainable anthropometric parameter which can be assessed in the outpatient setting. Measurement of the waist-hip ratio is more difficult as accurate measurement of the hip circumference may not always be possible since it requires the difficult task, especially in the women in India. Further, change in the waist-hip ratio may not accurately reflect the extent of obesity or change in the weight. A recent meta-regression analysis of prospective studies of the waist circumference and waist-hip ratio as predictor of cardiovascular events has shown that both the measures are associated with the risk of incident cardiovascular diseases. The currently recommended cutoff of waist circumference of more than 102 cm in men and more than 88 cm in women are not applicable to all the population due to heterogeneity in the average level of measurements and different relationship with cardiovascular risk. Asian Indians appears to have higher morbidity at lower cutoff for waist circumference than do white Caucasian. Now let's see obesity among children. The prevalence of obesity has tripled since 1980 among children of 6 to 11 years of age and the adolescents of 12 to 17 years of age. According to the National Health and Nutrition Examination Survey, NHANES, the overall prevalence of obesity in children in the US was 17%. A subsequent analysis suggests that the prevalence may have reached a plateau, although further tracking of the data will be needed to confirm or refute this. For children and adolescents, overweight and obesities are defined using the age and the sex-specific monograms for BMI, that is body mass index. Children with the BMI equal to or exceeding the age gender specific 95th percentiles are defined as obese. Those with the BMI equal to or exceeding the 85th but are below the 95th percentiles are defined as overweight and are at the risk for obesity related comorbidities. Childhood obesity affects both the developed and the developing nation of all socio-economic group irrespective of the age, sex or the ethnicity. Worldwide, over 22 million children under the age of 5 are obese and 1 in 10 children are overweight. A wide range of prevalence level exists with the prevalence of overweight in Africa and Asia averaging well below 10% and in America and Europe above 20%. Obesity has become a serious public health issue affecting a significant proportion of population in the countries like US. Overall, among adults aged at least 20 years in 1999 to 2002, 65.1% were overweight and 16% were obese. Asian countries are not immune to this phenomena. In China, the prevalence of the overweight and obesity among children aged 7 to 9 years increased 1 to 2% in 1985 to 17% among girls and 25% among the boys in 2000. Some of the commonly used growth reference charts in UK are the British 1990 growth reference charts and the International Obesity Task Force growth references. Though the IOTF thresholds are appropriately used nowadays, but further research is needed on the relationship between body shape at men metabolic markers and ethnicity in children and among the adolescents. The International Diabetic Federation (IDF) recommends that the use of waist circumference rather than the body mass index to define the obesity because of the link between diabetes and abdominal obesity. For adults, the IOF's definition has been adapted for ethnicity. For children, their definition of obesity as a waist circumference at or below the 90th centile based on the USA specific growth curve applies to all the ethnicities. The IOF advocates the use of ethnicity specific centile charts where these are available. The prevalence of childhood obesity among African American, Mexican American and Native American is highest as compared to the other ethnic groups. The Centers for the Disease Control reported the prevalence of obesity to be 19% of non-Hispanic black children and 20% of Mexican American children compared with 11% of non-Hispanic white children in the year 2000. The overall prevalence of childhood obesity continued to increase during the first half of this decade. That is 17% in 2004 versus 14% in 2000. However, the differences by race or ethnicity appears to be diminishing, in part due to the rapid increase in the obesity in white children. The disparities were found in children of other race or ethnicity in adolescents. The prevalence of severe obesity, that is of BMI more than 30, was 39% in the Native American boys compared with 14% in both non-Hispanic white boys and black boys. It was 14% in Native American girls as compared with 10% in non-Hispanic white girls and 18% in black girls. The prevalence of obesity in Asian American boys and girls was 10 and 4% respectively. Pubertal maturation is known as to have an impact on the obesity development. Girls who mature early have a higher BMI and the sum of the skin folds during their teenage years than the girls who mature later. And this interaction is strongest in the black girl. Because black girls undergo pubertal maturation earlier on average than the white girls, differences in the pubertal maturation stage can account for some racial differences in adolescent obesity. Many researchers have placed the origin of the childhood obesity epidemic at the beginning of 1980s. There have been dramatic change in the nutrition and physical activity habits of USA children along with the changes in demographics and societal norms, concurrent with the increase in childhood obesity prevalence. Obesity in childhood is a significant predictor of obesity in adulthood as well. The Bogalusa Heart Study tracked 2,400 5 to 14 years old children for a mean of 17 years and found that obese black children were even more likely to remain obese as adults than the obese white children. Childhood experience of the socioeconomic status can be defined by the race or ethnicity, household economic resources, or some combination of the both. Measures of accumulated wealth and access to different resources and services are usually not included in the studies of childhood obesity. The causal relationship between socioeconomic status factors and obesity rates cannot be arrived at the cross-sectional studies data. Controlling for the socioeconomic variables, however, is very difficult because many, if not most of these variables are unobserved. Thus, some researchers have cautioned against resorting to default explanations based on the race or ethnicity or the culture. Let's have a look at access to energy-rich food. The fast food, snacks and soft drinks have all been linked to the rising obesity prevalence among children and youth. Fast food consumption in particular has been associated with the energy-dense diet and to higher energy intake overall. Calorie for calorie, refined grain, added sugar and fat provides inexpensive dietary energy while more nutrient-dense food cost more. Whereas fat and this sweet cost only 30% more than 20 years ago. The cost of the fresh produce has increased more than 100%. Living in the high poverty areas has been associated with the higher prevalence of obesity and diabetes in adults even after controlling for individual education, occupation and income. In the Harvard geocoding study, census-tract poverty was a more powerful predictor of health outcome than race or ethnicity. The California Fitness Gram data showed that higher prevalence of childhood obesity was observed in lower income legislative districts. Low socioeconomic status or discrimination by race or ethnicity may cause stress. Stress has a direct effect on the hypothalamic pituitary adrenal axis, resulting in elevation of plasma cortisol, which has been implicated in the development of obesity. The relationship between stress and illness differ markedly by race or ethnicity, in part due to differences in exposure to social and environmental stressors. The degree to which the environment, socioeconomic status, and discrimination are appraised as stressful, culturally appropriate strategies for coping with the stress, biological vulnerability to stress, and the expression of stress as the illness are some of the other factors. Culture, unlike instinct, is learnt. It is distributed within a group in that not everyone possesses the same knowledge, attitude, or the practices. Among the shared understanding embodied by a culture are those pertaining to obesity, including understanding of its cause, course, and cure, and the extent to which a society or ethnic group views obesity as an illness. Culture can influence the perception of the risk associated with obesity. Studies of Latinos have found that many mothers of obese children believe their child to be healthy and are unconcerned about their child's weight, although these same parents are likely to believe that obese children in general should be taken to a nutritionist or physician for help with weight reduction. Now let's summarize the module. As we have understood so far that there is no straightforward relationship between obesity and ethnicity. Many more studies are needed to understand the ethnic and the gender differences in obesity prevalence. Continuous debate about the applicability of the obesity across ethnic group for adults and children goes on for a given BMI. The proportion of body fat differs between different ethnic group and the rate of maturation during adolescence in groups among children. The difference in the prevalence of obesity-related conditions such as cardiovascular diseases and type 2 diabetes across different ethnic groups can only be explained by a complex and as yet unresolved interplay of genetic susceptibility and environmental factor. Data are scarce for several ethnic groups. A number of studies have highlighted a relationship between ethnicity and obesity. Some of these studies are the local studies, while others are national level studies. Age variation among these studies and consideration of overweight only or overweight and obesity together differ, so comparison cannot be made. Thank you.